This is the fourth and the final webinar that CEPT in association with IIT Palakkad and BMGF has been organizing. Today we will talk about the ISO 31800. And just to give a background that this whole series of ISO on non-sewered sanitation, as we will hear at the end of this webinar, that almost 35 countries are in some process or the other to adopt this series of ISO standards. And so I think all the participants in this webinar, there are the people who are going to speak today are the people who have been instrumental in developing these standards. And so it will be great to hear from them. So, and once again, thank you all for joining this webinar and the series of webinars. Our team will ensure that these series of webinars and their recordings and the presentations will be available at the end of this. So just write to us for a link, but it will be on our website and the IIT Palakkad's website. So, okay, over to you, moderator, madam.
Thank you, Professor Dinesh Mehta, and greetings to everyone who are in this webinar. I would like to invite Dr. Roshan to welcome the gathering, and after that, I would be moderating the session, starting with the agenda which we have already shared. So, Roshan, to you for welcoming the people.
Thanks, Devshana. I'm so excited to see this session because we already, I think this is fourth session, right? Fourth webinar, and then this is quite important webinar. Now we are starting today. This is something like we talk a lot about the fecal sludge management system, treatment system, how to make it standardized. All those things we'll be discussing today. The 31800 ISO 31800 standard is really very much critical one. And a lot to learn from here. And I'm so excited to see all the speakers, especially like our colleague Chris from the TU Sud, and Mansoor, our colleague who really worked with the fecal sludge treatment system since last 12, 13 years together with us. And we have a Professor Mark from the from Duke University, and he's our trusted partner for a long time. And my colleague, Sean Kim, of course, he's our colleague who engaged in the development of this standard and working for a long time on standard. So it will be very interesting to listen from them, and we'll be understanding why we need ISO 31800 standard to standardize all the fecal sludge treatment system that is operating in different parts of the world. And I really welcome all the participants to join this event, and then like to get your feedback how the standard really can be adopted in the developing world, and then so that we can really initiate those kind of things in the different countries. Thank you so much, especially India. I'm so glad that our colleague, especially Professor Dr. Chaurasia from the Ministry of Housing and Urban Development, also joined. It's really great to see him here. And I'm sure many other countries, public officials must be coming and joining here. And then their engagement is very much critical in this kind of event. So I really welcome all the public officials and the senior public officials who join in this event. And after this event, we'll be again talking to separately with the person like Professor Chaurasia, Dr. Chaurasia, and other colleagues to discuss that how we can adopt or implement this kind of standard in countries like India, Bangladesh, or wherever the participants coming here. Thank you so much. Yeah, looking forward to hearing this session.
Thank you, Dr. Roshan, for the welcome note. I am Dr. Devasena, Chief Technical Officer of Global Sanitation Center of Excellence, IIT Palakkad, and I would be moderating the sessions. So the first session, the first talk, we will begin with Sun Kim, emphasizing the need for ISO 31800. So Sun Kim needs no introduction in this forum. He is the ISO PC Chair, 305 Chair, ISO PC 318 former Chair, and he's a consultant at SGK Consulting, focusing on development and implementation of international standards for non-sewered sanitation for the developing and developed world application for customers that currently do not have access to safe, affordable, and sanitation systems and services. So most recently, Sun was a senior program officer on water, sanitation, and hygiene team at BMGF, working as a product development and compliance manager. He joined the foundation way back in 2014 and supported all the efforts enabling access for billions of people in the sanitation sector. So as a member of this transformative technology commercialization team, he has managed philanthropic investments in the area of international standards development, implementation, testing, and certification for reinvented toilet development and commercialization, working with several R&D organizations and entities. So welcome, Sun, for the talk, and we would like to hear more from you.
Great. Thank you, Dr. Devasena. I'm so happy to be here. Again, my name is Sun Kim, and thank you for my esteemed colleagues for the very nice introduction. I really cannot believe that this is the fourth and final in the series of these webinars. So I'm very happy to be here, and I hope this is interesting to you. Now, most of the slides will be refreshers from really webinars 1, 2, and 3. And there is one slide that I'll go into a little more detail, but it'll primarily be a refresher. So with that, and as Dr. Devasena mentioned, I'm a current ISO PC 305 chair and former ISO PC 318 project committee 318 chair is where the ISO 31800 came from. Jigasha, I don't see the presentation. I just see the auto save. I don't know if others are seeing that, but if you could share the presentation. Yeah, I'm just seeing the auto save off button. Is it just me, or is
no? I think
everyone
there's some glitch. There's some glitch. Just give me a moment.
Got it. Okay. It could be my computer too. It's
no, it's
technology is
also on
great.
us. Yeah.
Yeah.
Just
Great.
hold on.
So as Jigasha is putting this on together, maybe I will just kind of go through this first couple of slides that you will see, just so we don't have dead air. You know, as we discussed in the introduction, you know, there is really a tremendously bad sanitation crisis in the world, and it of course affects every country in the world. If we could just go to the next slide. It affects every country in the world, but particularly developing countries. But even in the country that I live in the US, there are many areas where sanitation is problematic. And, you know, per the joint monitoring program by the World Health Organization and UNICEF, currently 3.5 billion people lack access to safely managed sanitation. And the tremendous toll it has on all humans, and particularly on young children, and preventable diarrheal diseases that go from fecal to oral contamination is tremendously heartbreaking, and really it is a human you know, human rights issue. And then if you go to the next portion, and the impact to women and girls particularly is extremely negative, especially considering that the impact in caring for sick and also poverty typically will have a much more negative impact on women and girls. So the next slide talks about the sanitation service chain, whether it's sewered or whether it's non-sewered systems. And in that service chain, there's always the capture, and then the conveyance, whether it's through sewer pipes or through trucks, and then ultimately treatment and reuse or disposal. But oftentimes this does not work in non-sewer sanitation, where the contaminated fecal material with all its pathogens just remains in the community. So the next slide is referencing the topic of our sanitation non-sewer sanitation webinar number 2, where we talked about ISO 30500, and this was the reinvented toilet and killing the pathogens, and really the containment and treatment all at the household or community scale, all on site. And that was, not that I'm just plugging prior webinars, which are available via recording, but that was on webinar number 2. The next slide references webinar number 3, ISO 24521, which was a management guideline that discussed the whole service chain. And the topic of today's webinar, ISO 31800, is that treatment system. Once the fecal material is collected and transported in mass, then what do you do with it? And so ISO 31800 defines the technical requirements. So the next slide. So I'll spend a little more time on this particular slide. So these are the key aspects of ISO 31800. So it's about a fecal sludge treatment unit, which is a component or a part of the larger fecal sludge treatment plant. Okay, now it defines the design, performance, and test requirements of such devices that would be manufactured and then assembled on site at a fecal sludge treatment plant. Yeah, and it is just like ISO 30500, which is for the household scale toilet and treatment system. This plant system is intended to be technology neutral. And we have the privilege of having engineer Mansour Fall, who's going to describe later in more detail 2 such type systems, dry combustion and pyrolysis system, as well as Professor Mark Deschutes, who's going to be talking about a supercritical water oxidation system. These are really exciting. And while this will not be presented, there is also another type, which is a mechanical vapor recompression system. And you can read more about it at cedron.com/varcor. So really excited to discuss these technologies, to hear more about these technologies that are intended to be compliant with most, if not all, the requirements of ISO 31800. And you'll also hear from Chris Chan, who's going to talk more details of the standard itself and also some testing that has happened. So ISO 31800 focuses on the treatment of fecal sludge to kill the pathogens, and also to any output is safe for the environment. So human and environment. So that's the common theme, is that that these systems should not have a negative impact on human health or environmental health. Another key aspect is that the systems, depending on the inputs defined by the manufacturer, can be energy neutral or positive, just treating fecal sludge alone. And that's a key aspect, so that the potential for these systems to not put more load on the current electrical systems or energy distribution systems. And again, the key aspect is treatment of human health and safety, but also of the environment. Another aspect is limiting odor and noise. Those are key. Those are things that can have a negative impact on the population near these plants. So the final point here is that since
Sorry, you got muted. Yeah.
Yeah, sorry. I think the host muted everyone and then in the process. So sorry about that. So the final element is that ISO 31800 requirements are typically more stringent than most local and national requirements, but not all. You know, you cannot make it so stringent that it's impossible to even design and comply. But because of that, the expectation is that these products will meet the standards. I'm sorry, products that meet the standard will generally comply with local and national requirements, which is a very important aspect. With ISO standards, the intent is that you meet those the requirements in the standard, but it's the local regulations that you also have to always comply with. So I know that's a little bit confusing, but we can go more into details if anyone has questions related to that. So the final slide, so the next slide is my final slide. And in there, you've seen this particular slide, but key aspects, again, is implementation of these quality standards will support the aspects of market readiness, which is to supporting the regulatory environment. Very important that you meet the local and national regulations, and also to have readily available competitive products so that the sanitation crisis can be resolved in a manner that is helpful to the largest population possible. So with that, I'll revert back to Dr. Devasena. Thank you very much.
Yeah, thank you, Kim, for emphasizing the significance of implementing quality standards, as well as underscoring the necessity for this kind of regulatory environment and highlighting the key aspects of ISO 31800. Thank you very much. And if there are any questions, we will be taking at the end of the session. Now let us move on to the next speaker. We have Chris Chan, Project Manager, Corporate Sustainability Office, TUV-SUD. He will be presenting on the scope and technical requirements of ISO 31800 and also ISO 31800 certification process. Before allowing the speaker to give his presentation, I would like to introduce the speaker. So Chris Chan, he joined TUV-SUD as a project manager with 5 years of experience with ISO 3500 and also as a technical lead in the development of ISO 31800. So with his tenure at TUV-SUD, Chris has validated these standards, tested with manufacturers, and worked with laboratories to bring up their capabilities in different countries in China, India, South Africa, and Senegal. So currently, Chris is working on certification of the first ISO 3500 product in the world and also the 5-year systematic review process for ISO 3500 as a project lead. Now I will request Chris Chan to present.
Thank you.
To proceed with the presentation. Thank
you. Okay. All right. Good morning, afternoon, and evening to some. So I'll be presenting the introduction to 31800. I hope most of you know something about it. If you don't, I'll be going through what is it about, basically. Next slide, please. Yeah. So I'll be going through a high-level overview of the entire standard. I will only be picking out the major specifications for the standard and then what makes it different probably from the other standards around, even for sanitation or non-sanitation products or plants. Yeah. So next slide, please. Yeah. So for ISO 31800, similarly to 3500, the target audience are usually the manufacturers. They need to know or want to know how to design their system according to certain standard or certain requirements that the market or the general industry is looking for. And then you have the government, regulators, and also the buyers who wants to buy or invest in such equipment. So they might want to look into the standard to see if plants or FSTUs are compliant to 31800 or even partially compliant to it. Okay. So I'll be going through the introduction and then the standards application, technical requirements, and then number 4 is energy independent assessment. It's something that is quite different from any other standards around. And then last but not least, performance testing, where what's coming out of the system, what are they being tested for? Okay, so comparison between 3500 and 31800. Just wanted to see a show of hands. If everyone could, sorry to hijack the chat. If everyone could use the chat to let us know. 1 for you are familiar with 3500. 2 if you are familiar with 31800. 1 and 2 if you are familiar with both, or maybe 0 if you are not familiar with any of them. Maybe could I get the participants to try to participate? Cool. I see quite a lot of 1 and 2, and of course 0 as well. That's why you guys are here. Amazing. Okay. So a lot of 1 and 2s, not what I expected, because I thought you guys were here to understand a bit more about 31800. But of course, after the presentation, if there's more questions, in-depth questions, detailed questions that I'm not covering, feel free to reach out to us as well. All right. Okay, so with regards to the slide, what's the difference between the two standards? Since most of you know the standards, the major differences are the 5 points in the boxes you can see, the green and the orange. 3050 is for use, has a user interface and a treatment unit, but 31800 is only for the treatment unit. So the next major difference is 3500 is a household scale, small scale, while 31800 is a community large scale system. So you can roughly visualize what's the difference between them. And then of course 3500, I need to be a bit specific here. It's not connected to the sewer, and it might not be connected to the electrical grid as well, but it also can connect to the electrical grid. So it's just an option. But whereas 31800, the FSTU is not connected to the sewer and also not connected to the electrical grid when it's running a steady state. So I'll go into more details later for this energy independence. And then the 4th point for both sides is the output, they are safely disposed or reused, and also supposedly not harmful to human health and the environment. Okay, and then last but not least, it might be interesting to some people who wants to do the testing and certification. The difference between 3500 and 31800 is a smaller system, you require 32-day testing and 5 months of field testing, whereas the FSTU is inverted or directly not proportional with regards to the size. It's only a 6 days test sequence. So you can see the cost, the duration significantly goes down and compared to 3500. All right. Okay. Next slide, please. Okay. So just general requirements. Whenever we start a testing or the manufacturer comes to look at the standard, one of the most important part is the FSTU needs to have input range of input criteria, input parameters. So the reason why is because we understand that anything can come into the fecal sludge treatment unit. So because the vacuum trucks are being collecting fecal sludge from household to maybe some pits to anywhere else. So they are not sure what is being dumped into these pits. So that's why there is usually a range of what is coming into the FSTU. And then this, before any testing is being done, the manufacturer or the operators have to tell us what are the range of parameters so that we can take into consideration if any of the days go out of range, we can sort of disregard the test because it's not it will be unfair to the operators or manufacturers. Okay. Next slide, please. Yeah. So sorry. Can you go back one slide? So I highlighted. So the primary treated fecal sludge will be the need for energy independence, but also secondary inputs. If you need biomass or wood chips or municipal waste to start the system, it can be put into the system as well without the need for energy independence. So only energy independence is only for primarily treated fecal sludge when it's at steady state. I just wanted to highlight this. Sorry, thank you. So next slide, please. So this is an example of what the manufacturers will provide to certification bodies like us. How much is the throughput, the moisture content, your fecal sludge, ash content, calorific value, even if you have heavy metals in the fecal sludge as well, what are they? Because it will affect what is coming out of the system. Okay, next slide, please. All right, so just a high-level technical requirements. The standard requires manufacturers to declare what's the downtime, maximum technical availability, and then there's documents involved with HAZOP and mechanical electrical requirements in the standard as well. And of course, anthropometric and ergonomic design requirements. For example, the maintenance, it should be easily accessible. And then, of course, the last but not least, the maintenance adjustment and maintenance requirements, where the points, is it accessible? Is there maintenance parts as well provided? Is it in the manual? So on and so forth. So the very basic kind of requirements for any plants, be it fecal sludge, treatment units, boilers, etc. All these are very standard in the industry. Okay. Next slide, please. Yeah, thank you. So product literature as well. Documents need to be submitted to the certification body, or at least requirements in the standard. System information, basic system information, safety and maintenance, complexity of the task. Do you need a high qualified person to do it? Do you need a lesser qualified people to do certain stuff? And then you have the sustainability part, which is minimal. It only talks about the consumables, what the quantity required for your operation, and then minimal GHG emissions declaration. And then, of course, resource recovered products. What's the type of resource recovered or potential resources that can be recovered from the system. So these are important information even for investors or buyers. Okay, next slide, please. All right, so energy independence, just like I mentioned, only for fecal sludge as a primary source. So as you can see, the last or the bottom picture, you can see that if it's for energy independence, the primary source should only be fecal sludge. But if you were to shut down, you can be connected to a solar system, a grid system, or even a hydro dam, you can see on the photo itself. And then after it's steady state, only fecal sludge can go through. And then it should run on its own, because what we found out is fecal sludge itself has sometimes a high calorific value or energy content, and also depends on what's the moisture content of what's coming in as well. So, but generally after it's dry, it's relatively easy to get energy independence for it to run by itself, right? So after going through the treatment system, similarly, I'm talking about the photo at the bottom. Energy is recovered. Be it you need an auxiliary generator to harvest the energy, be it maybe it would be methane or heat, for example. As long as you can recover the energy and then convert it back into the system, you're considered energy independent. And of course, if you have additional energies, additional electricity or heat that's coming out of the system that you do not need, this is a plus because it will be energy positive. All right. So on the right box, you can see the example of an energy balance. I think everyone here who's an engineer should be quite familiar with this. And then just that the standard has templates as well for people who are unsure what the energy independence is about, how to create such a balance. But of course, during certification, the technical expert from the certification body will advise or even will do the calculation for you. All right. Next slide, please. Okay, so performance testing, I mentioned it was 6 days. So what will be tested is entire suite of upper throughput limit and entire suite of a lower throughput limit. So what will be one suite of testing is you can see on the right side, it will be solid and effluent 1 day, air emissions 1 day, air emissions for dioxin and furans for 3 days, and then noise measurement for 1 day. So a total of 6 days. But then if you have 2 suits, then it'll be a total of 12 days in total. Okay. And then as I mentioned, the defined input has a range, but even the defined input when we are testing has a buffer of plus minus 5% as well. So additional what do you call it, buffer to the entire testing as well, because sometimes the loading is done manually, sometimes the input flow rate might differ here and there, so there's always a buffer in place. Okay, next slide, please. All right, and then almost the last slide, we have the performance testing, which usually a lot of people are very concerned of. So what are being tested for the system and what's coming out of the system are being tested. So the output, be it solid or effluent, human health is being tested for bacteria, virus, protozoa, and helminth. And then for the environmental part, will be the usual COD, BOD, TSS, TNTP, and then there's a list of transition metals as well. And then for the air emissions, you have the
Anu Thomas, South Africa.
So air emissions, there'll be carbon monoxide and then the usual air pollutants. And then you have dioxin, furans, as arsenic, cadmium, mercury, and so on and so forth. All these are gotten from, during the standard development, they are gotten from usual plants such as boilers, incinerators, etc. So the delegates during the development of standard discuss what could be the possible pollutants coming out from the fecal sludge treatment unit, and also what are the usually input coming in to the fecal sludge treatment unit. So with this, we came up with a list that's currently in the standard. Yeah, and then 4 and 5, basically acoustics, 4-point measurement in the north, south, and east and west. And then we have the odor measurement as well, which includes human assessors. All right. So I think this is my last slide. I'd like to do a poll again. Sorry to hijack the chat. I just want to know which parameter would be most important to you. Is it 1, human health, 2, environmental, 3, air emissions, 4, acoustics, and 5, maybe odor? Could the participants input into the chat 1, 2, 3, or 4 or 5? Which is do you think is important to you? 1. Oh, okay. Odor and health. I see health as well. 1. 1, 2, 3. Human health, environmental, and air emissions. So I don't see much of a 4. So noise might not be important to most people, but just to share with everyone as well, during the development, it was taken into consideration that this FSTU might be near to communities. That's why acoustic and odor is important for the participants or delegates as well. That's why we needed to put the acoustics and odor. All right, so I think I see quite a lot of 1, at least majority to 1 and 2, human health and environmental. So nice to see that. All right, thank you very much. I think next slide will be my thank you slide. All right, if there's anything, feel free to reach out to me or even to any of the speakers, because all of us, we know the standard quite well. All right, thank you very much.
Thank you, Chris, for such a interactive presentation. You have made us very active during your talk. So you have given us an overview also, including the comparison of both the standards. You have discussed the general requirements concerning the inputs like fecal sludge, and for each feedstock, what should be going in as inputs, including the energy independence assessment. And you have also outlined the test sequence in performance testing along with the thresholds for this. Related to the talk will be taken at the end during the Q&A session. Now let us move on to the next speaker. We have Manzoor Fall, who's our next speaker, who will be speaking on the potential application of ISO 31800, combustion and pyrolysis as example. So before requesting Manzoor to give the presentation, I would like to introduce Manzoor to the audience. So he has worked on at different capacities in different organizations, including as a PMP engineering manager, and he has experience in the hotel group as engineering director, and later he has launched his own company specializing in energy saving and renewable energy, where he had the opportunity to do training in energy audit and also in clean development mechanism. And later he worked on waste treatment and recovery units as well as sanitation, with participation in the technical committee which set up the 3 standards on sanitation: ISO 31800, ISO 24521, and ISO 30500. Manzoor joined the FSM Alliance as an independent contractor, acting as a liaison in the year of 2022, and became BMGF's independent consultant since October. So we welcome Manzoor for this talk. Over to you.
Thank you. Thank you for this presentation. Good evening or good morning, everybody. Yes, we're going to go through some example of application of what we call omniprocessor, and we're going to try to make it very simple and very digestible, so maybe they can help to see how this ISO is used. So we just start by just talking about the concept of omniprocessor. So any technology, any industrial system is defined by its function. There's a primary function of any system, and there is some constraint function. So let's say the primary function of a mobile phone is to call, and there is some constraint function. It should be small, it should be this, and there is some additional feature. So the omniprocessor is the same thing. So the primary function is, it's an industrial unit that processes the sludge, thermally to kill pathogen while reducing the volume and generating some byproduct, as the Sun Kim says. Killing pathogen and reduce volume are the primary function of this system. And while doing that, some will just generate some byproduct, and that will make it sustainable. Next slide. So we have some pictures of different configuration. We have the combustion system. Yes, the combustion system. You have the pyrolysis and you have the gasification. We're gonna go to define one of this concept, and then we're gonna give an example of what's existing in the world. Next slide. So this is an example of combustion system. Combustion reaction is usually happen when you have oxygen, fuel, and ignition. When you have these three elements, you have combustion. So there is a different theory in the definition, but it's a reaction that produces fire. To make it simple, it takes place at a relatively elevated temperature. It's a heat releasing redox chemical reaction that usually occur between a fuel and an oxidizing agent, mostly oxygen. Here it's oxygen. So this flow diagram is coming from Cedron. Cedron is one of the first manufacturer of OP omniprocessor, though the first prototype was designed and built and operated by Cedron. And it's a very simple process. They take somebody is talking, maybe. Yeah. Okay, sorry for that. So yes, basically what the OP is doing is taking the sludge and taking his characteristic of organic material and using it as a fuel. If you took the power plant, they take fuel. If you took any biomass power plant, they take some biomass because it's organic alone, and they get energy out of it. So that's what happened basically in the omniprocessor. You take the sludge, it dry it out, because if you have water, it becomes very difficult to get fire out of something very wet. So you remove the water from that. After removing the water, you bring it to the boiler. In all power plant in the world, you have boiler. Boiler is taking the chemical energy, transform it into thermal energy, and transform in mechanic, and later after in electricity. So here you have that process. From the left, drying, remove the water. And in the middle, in the boiler, is heating and taking the heat from the sludge, from the burning, and transfer this heat to the steam engine and generate electricity. So main function is killing pathogen. In the dryer, the pathogen are killed because the temperature is around 100 degrees C. 90 degrees C, based on World Health Organization, all the pathogen are killed. That's the killing the pathogen function. Reducing the function of the sludge is happening in the boiler. When you burn it, 30% of the sludge become ash. You release the rest of the quantity, and that's where you have your reduction. Now, when you reduce the volume in the boiler, you generate heat. So the heat will go to run the engine, and this engine, that's when you have some product out of it. When you dry the sludge, the steam coming out of the dryer will go to another process to cool it down, clean it. That's where you have your water. This is the byproduct. And non-burnable ash element called ash, 30% of the system of the sludge, income sludge, is used as a fertilizer combined with the compost, or used as a substrate of civil engineering construction. Next slide. This is the initial system of combustion system. So now, go previous one. The second generation. When they finish that example of omniprocessor, they just give the licensee to more company like Anko that are installed in India. They come out with different approach. They say, okay, we need the basic system, but we need to do the pre-treatment. What happens if there is no FSTP available? So they add some additional element that do the pre-treatment. Pre-treatment means separate liquid solid, treat the liquid, and handle the solids. So the primary function is there, but they add some additional function like wastewater treatment, not wastewater in terms of networking sewage network, but all the sludge is coming freshly in the system, and they put a bullet press to do the separation liquid solid. So the septage is going to the dryer, and the dryer will just dry it and send it to the boiler like the initial one. And the water is go to the MBBR that go into the normal process of treating, and out of that you have your let's go process water. So this is the second generation of OP, and an example of this is available in India in Vadodara plant. That's how it runs. And now the system is evaluating because we have now additionally Cedron was the first who did it in 2014, 2016, 17. Ankur joined the team and developed a second generation. Now they're working on the third generation of omniprocessor, what is more integrated. Next slide, please. So this is the third generation of OP. What does it mean? As they're evaluating, as they're negotiating with the customer, they realize that there is more needs. Some people need more compact system because there is some stress. So that's the customer driving option. And then in this configuration, they just imagine that you can dump right in the system, have your component that do the filtration, you have the screw press that doing the separation liquid solid, and you can treat your water, and you have your initial OP that will just do the sludge treatment. So this will compose by a water treatment system and the sludge treatment system. At the end of the day, you have your output. But what is interesting, what is the add value on that is you treat in the sludge, you treat in the water, but you make it compact. And you don't require a lot of space for that. This is the third generation, and some customers are requiring some code generally, and that what bring the manufacturer to just design this similar approach. Next slide. So, and this is the generation as well, how it will be configuration. You see the emptying truck dumping right in the machine. So if you require like 2 hectares for a normal FSTP, for this one, you just require something like 400 square meters and everything can work. And this is having some advantage because it can fit anywhere and you can handle the stress of the urbanization. Next slide. Now, as we talk about combustion, there is another system called pyrolysis OP. So pyrolysis is the heating of organic materials such as biomass in absence of oxygen. So the sludge is an organic material. There is 3 ways to valorize it. One way is to burn it with oxygen. It's called combustion. We see the different example of combustion system. The other way is without combustion, heating up. That's what we call pyrolysis. Or you can have controlled oxygen and heat it up. That's what we call gasifier. So depending on the process you are using. So combustion is more heavy. Pyrolysis is lighter than combustion in terms of component. You can heat it up without oxygen. That's what happened. There is different example of pyrolysis system installed in India, in Hawaii, in 3 states in India. And it can fit in 3 containers. That's why you see the pictures. It's not very big. It can suit for small scale requirement. And that's what we have in different configuration. And it doesn't require high level of skills in terms of technicity for the operator as well as for the design. Next slide. This is the one installed in Y. And just simple, you can see it can fit in just like 4 containers. They have 2 units, and each of them have like a simple pyrolysis system, a drying system that feeding the pyrolysis, and it works. So that's an example of a pyrolysis OP. Next slide. Okay, this is the example of combustion omniprocessor installed in Dakar, Senegal. So the configuration of this one is, there is an initial design, the first primary design. This is the second generation. This second generation is, it will take, in additional to the sludge, some municipal waste, like paper, cardboard. That's why in the right side, you see there is 2 boxes. These 2 boxes is for the feeding system. One will take the dry sludge and one will take the paper, cardboard, or paper. And this machine was installed in 2019. And since that moment it's worked. So it's basics. It take the sludge, dry it, send it to the boiler, burn it, take energy out of it. And while drying it, the steam is coming out, is condensate, and it go through a process of treatment, and they add some chemical on it and produce coolant. And while they burn it, they generate some energy out of it, and this energy is used for the machine itself. This is a second example. Next slide. So as we, yeah, next slide. As we talk about example, the first and the second generation were able to generate ash. All of them generate ash. A combustion system generate ash. So one part of the use of the ash is paper blocks. So these were produced. Oh, can you go back, please? Yeah, these paper blocks was done with the first generation of OP, because whatever happened in the OP, we are sure that when you burn it, you have ash out of it. Generally, 30 or 40% of the sludge is become ash. Ash can be used as a substitute of cement. So rather to use 100% of cement, you can use 40% of cement, 60% of cement, sorry, and 40% of ash, and have paper blocks with the same characteristic than if it was 100% of cement. So that was tested in 2015, and since that moment, the demand is very high, because as soon as people know that it's coming from the sludge, they call it organic pavers, and they want to have these pavers. So this is an application of bioproducts coming out of the omniprocessor. Next slide. And yes, talking about fertilizer as well. So when we have one part of the ash used as a substitute of cement, one part can be used as a fertilizer. It's not directly used, but you mix it with the compost. And they realize that with the compost, mixing the ash, it becomes a very organic mineral fertilizer and can replace the synthetic fertilizer used in the field. So all the people that are doing organic farming are very interested in this. So since the first one was installed in 2014 to now, the company that running the omniprocessor sells something like 90 tons of fertilizer. And some survey was done in these farmers, and they were very happy because they realized some advantage on that. No chemicals, there's no heavy metals here, and they don't destroy the soil with this chemistry fertilizer. So this is the second byproduct coming out of this machine. Next slide. Coolant. As I say, is when you have combustion, you need to dry the sludge because the sludge comes with some moisture content. If you have some wood with the moisture content, if you try to light it up, it will be very difficult to light it up because there's a moisture content. You also need to dry it, and then you can burn it easily. That's what happened with the sludge. We dry it in the dryer. Then when you dry it is just heating. When you heat something to 100 degrees C, all the water that are inside the system will be released in terms of steam. This steam is collected and cool down. It's cool down, condensate, they call it. When it's condensate, they just treat it, filter it, they remove all the element coming with that, and add some chemicals, and that become coolant for engine. They can put on the car. Why coolant? Because the market of the car was very open for coolant for engine. No entity was producing coolant. They were just buying all the coolant from the foreign countries. So there was a market of coolant. In certain countries, there's a market of water distiller. For example, if you go to Vadodara in Gujarat, they're producing water distiller because there is a market for water distiller. And other countries have different demand. But the basics is that when you have your omniprocessor, you can generate some processed water. And depending on the market, you can use the processed water for different purposes. So in Dakar, they use the coolant. And the proposal value of this coolant compared to the other one was it come from the West water, and people were just happy to have it. They call it organic coolant because it's coming from the West. That maybe make it marketable. Next slide, please. Thank you. That's all we have in terms of example of omniprocessor, combustion system, and pyrolysis systems. And yeah, there is different 2 units installed in Senegal. There is 1 unit installed in Vadodara, and there is 1 unit installed in Bangladesh. And all of them are combustion, and there is different pyrolysis system installed in India. So if you have any question, I'm here. Thank you.
Thank you, Mansoor, for the presentation, for giving us a vivid explanation of the thermal technologies and also the end products out of this technology, like how these processes are integrated in the omniprocessor technology and categorized as first, second, and third generation, and seeing the products, like multiple products out of the technology is also very encouraging. So as I mentioned earlier, we will be taking the questions later. Now, thank you very much for the wonderful presentation, and let us move on to the final speaker of today's session webinar. We have Professor Mark with us. Professor Mark will be speaking on the potential application of ISO 31800. So based on supercritical water oxidation as the FSTU, predominant FSTU. So before requesting Professor Mark to present, I would like to introduce Professor Mark, the professor in the Department of Civil and Environmental Engineering at Duke University. He is also the co-founder and head of technology of 374 Water, which is a NASDAQ-listed clean tech company dedicated to the commercialization of supercritical water oxidation. So Professor Mark has 3 decades of experience in developing and optimizing novel waste to energy processes, including green processes for pollution control and resource recovery. He holds a degree in chemical engineering, and he is also a fellow of American Association for the Advancement of Science. So I welcome Professor Mark to present us on the potential application of supercritical water oxidation process. Over to you, Professor Mark.
Thank you very much, and thank you for the opportunity to speak. As was said, my name is Mark DeZeus. I'm a professor at Duke University, but I'm also the co-founder of 374 Water. So I'll be speaking from both these angles as a researcher and developer of technology, as well as someone involved in this company, 374 Water, on the tech side. Next slide, please. To start, I want to, just go back to where around 2011, 2013 is when the Bill and Melinda Gates Foundation effort on revolutionizing sanitation. I'm sorry, I'm just stuff popping up. Yes, started to reinvent the toilet. And it's around 2013 that I received the initial funding at Duke University to develop. I did not invent supercritical water oxidation, but we made it work at scale. And so this was the initial funding to build a pilot system that could treat fecal sludge, treatment in a box. And then, fast forward to 2018 is when I co-founded 374 Water to take it commercially. We're now, as was mentioned, listed on NASDAQ. We have about 30 employees worldwide, and we're commercializing, this treatment that we call SCWO in a box. So what is SCWO? That's, the point that I will be talking about during this short presentation, trying to explain what it is, what it can do, and how it fits with the 31800 standards. Next slide, please. So where we started was looking at this picture, and you can look at it and say, well, this is fecal sludge being dumped, but you can also look at it and say, this is energy. And how much energy is in this barrel? It's roughly 87 kilowatt hour. How much is that? At the same time, it's a lot, and at the same time, it's fairly diluted in water, but it's the same energy as 10 liters of gasoline or the energy in a Tesla battery pack. And the question then was, can we develop a technology that can harness this energy, sanitize the waste, recover resources, and do it with the energy that is embedded, this 87 kilowatt hour. And this is where supercritical water oxidation comes in the picture. Next slide. So on this slide, what you see is a phase diagram of water. And we're all used to think of water coming either as a solid, a liquid, or a gas. It turns out that there's a fourth state of water. If you heat and compress water beyond what is called a supercritical point, or the critical point, which is above 374 degrees C and roughly 220 times atmospheric pressure, water becomes supercritical. And what is that? It's neither a gas nor a liquid. It has amazing properties. It's semi-dense. You have very rapid heat and mass transfer in supercritical water. And that allows amazing reactions, oxidation reactions, very fast reactions you happen in the presence of an oxidant. And we use air to provide the oxygen. And what you see is the reaction that's illustrated at the bottom of this slide, where any organic slurry, you don't have to dewater, you don't have to dry the waste. Any organic slurry compressed and heated above the critical point, you add air, and it will very rapidly react to mineralize all the organic elements and yield the most stable form, that is water and CO2. The minerals fall out of solution. This is an exothermic reaction, so you recover the heat of reaction, which is used to preheat the waste and bring it to supercritical condition. And surplus heat can be converted to electricity. All of this is extremely fast. It happens within a few seconds. Next slide. So it is truly a transformative technology. It is novel. It's not just incremental. It's not assembling just a few known technologies together. It is different. And what you see on the right-hand side is this 1 ton a day pilot system that was built and run for many years at Duke University with the funding from the Gates Foundation. Again, 1 wet ton a day, it was in a 20-foot container. And why I think it's a transformative technology is because the units can be made very compact, very small. We can therefore treat the waste at the source or embedded in a community. And we recover resources, clean water, minerals. I'll show you pictures in just a few seconds. You can do it in a very efficient way. Next slide. So what's in the box that 374Water is commercializing? So this is a high-level diagram of the process. And you can't see my mouse, but look to the left. You enter with the wet waste, and it is preheated. And there it will meet compressed air that is also preheated through a standard scuba diving compressor. And then it passes through a long tubular reactor where the oxidation reaction occurs and the temperature increases. And there downstream, it's all about phase separation and energy recovery. The streams get separated. The vapor and the compressed gas get expanded, resulting in a harmless gas that is vented and condensed water that is distilled quality water. About 40% of the water comes out as distilled quality water. The rest pushes the minerals through a cooler, and you yield a stream, a dual phase stream with minerals and water. So just to recap, what enters is air and wet waste, and what comes out is a harmless gas, distilled quality water and minerals. And depending on the scale, this can be made energy neutral or energy positive, or consumes a little bit of energy. So that's the gist of the process. Next slide, please. So these are some of the waste that we've treated at Duke in our pilot. You can see on the top line a heavy focus on fecal sludges and sewage residues, animal waste, but we've also done food waste, chemical waste, pharma, food and beverages, and mixtures of these. The commonality between all these wastes is that they need to be concentrated. Oftentimes I say milkshake, not tea. And what I mean by that is we need the calorific content in order to have the highly exothermic reaction to power the heating of the waste to the supercritical conditions. So when we treat, for instance, when we treat landfill leachate, we need to add a co-waste or a co-fuel. And this can be an alcohol, it can be diesel, it can be fat, oil, and grease, or any other kind of high energy content waste. Next slide. The beauty of the process, as I indicated, is that what comes out is fully mineralized and extremely clean. So you see some examples here of pictures of things that we have treated, whether it's fecal sludge, animal waste, or leachate. it always comes out the same: clear water that has no odor and the water quality is excellent, and minerals that fall out of solution. Next slide. Here's some examples, and these are just average values, indicated values of the influent and effluent when we treat sewage and wastewater residues. So you see a very high inlet COD and very low values in the effluent. Nitrogen is also reduced. We're losing nitrogen as nitrogen gas in the process. However, we concentrate the phosphorus in the solids that is collected at the effluent. There's a great reduction in conductivity because of the minerals that fall out of solution. Next slide. A very interesting feature of the process is because it's an advanced oxidation, is that we oxidize all kinds of organics, even very recalcitrant contaminants or complex structures, as you can see to the right-hand side. And that includes all pharmaceuticals, drugs, hormones, chlorinated, brominated, fluorinated compounds. PFAS is an emerging concern in biosolids and biological residues from wastewater treatment plants, and these also get mineralized. And that to the same extent as other organics, so 99.99% and more elimination. So it allows us to say that SCOR treatment is waste agnostic. It will really mineralize all the organics that we have in the waste. Next slide, please. We always get the question of energy balance. So this slide shows the input and the energy requirement or output projected for the commercial units that 374 Water has in the works. We're currently, 374 Water is currently commercializing what we call the CWAS-CRDF-CEPT for 6 wet ton a day. It's one 40-foot standard shipping container. I'll show you a picture in a minute. And that unit will take about 6 wet ton a day at 15% dry solid. Roughly, that's the sweet spot to have the right calorific content. And it will use roughly 10 kilowatt hour or 240 kilowatt hour per day. And this has certain assumption on the energy recovery. Again, these are projections. We will produce a large amount of heat. We have a lot of heat recovery in the system, but we have low-grade heat that can be used to heat up buildings or dry food or fish or tea or anything, any use that you can think. At larger scale, the CWAS-30, which is not yet fully designed, we project that the unit will be 3 containers and that will actually produce electricity with similar input. And that's because of the economies of scale. CWAS-200 is not yet in the design phase, and so we expect these units to be custom, but it will produce even more. And so what you see is that after, say, the CWAS-30 is started and is running continuously and can be it can be run off grid. Next slide. So this is a picture of what these units look like. This is the first system that will be moved to Orange County Sanitation District in Southern California. Again, a 140-foot container. Next slide. So since this webinar is focused on the ISO standards, I've put this table together to see how we project doing with respect to the standard. And I picked a few criteria as Chris shown. There are many, and I just picked a few. So on the first line, the question of energy independence, which in a nutshell says the unit shall be able to run just on fecal sludge input and be able to run off grid just on the energy embedded in that fecal sludge. And as I showed in the previous slide, this will not be met with the CWAS-6. This is just not possible with the supercritical water oxidation process as 374 has designed it However, we expect it to be met at the air score 30s scale. And this is with sludge at roughly 15% solids. In terms of health parameters, helminth, pathogen indicator, bacteria, etc., it's very obvious that we will meet all criteria. The temperature in the process greatly exceeds any temperature that destroys living organisms. So they will have 9 log reductions or more, and so we'll meet these criteria. The metals and trace elements, that is to be determined. We don't know yet. It's largely input dependent. And since we can specify the inputs, that's something that we'll have to fine tune and figure out how to meet and how to operate the system in a way that will meet these requirements. And then I listed BOD, COD, pH on the liquid side, and we expect these to be met. We don't have measurements yet, and these measurements were all done on the pilot at Duke. We don't have measurements for BOD, but we expect COD and pH to be easily met. And we have some data on gas emissions. Actually, we have quite a few data on gas emission. We're way below the thresholds that are stated in the standard. The unit doesn't release any odors or any significant odors, so we'll likely pass that. So this is to be seen in the future. It's certain that we're keeping a very close eye on ISO 31800, and it will seek certification under the standard. Next slide, please. I have a couple more slides. I want to share with you some of the things that I'm excited about. I mentioned that the air SCWA system is really for concentrated waste. But we have some ideas about merging it with a membrane bioreactor for a combination that would be able to treat sewage, and that would enlarge the window of application. So imagine some sort of waste feed in the range of a few thousand cubic meters a day being treated in a membrane bioreactor, and all the solids, including the kitchen waste, organic waste of a small community, could then be separated and treated in the air SCWA system for recovery of resources and returning the water to the other treated effluent from the MBR package for reuse. So this is one way that our system can be integrated in a decentralized treatment. And next slide, I want to share a project that we are an active participant of in deploying the air SCWA system in a resource-constrained setting. And so we've been working with partners, in particular an NGO called Global Partners for Development, GPFD, and you can see the web address there, on deploying a demonstration, but it's more than just a technology demonstration. It's about providing an ecosystem for data collection as well as for waste management and resource recovery. And in particular, we're targeting the region of Homa Bay, which is near Lake Victoria. And we're working with the local branch on the ground, with the local government, with the University of Nairobi, to put this project on the ground and show a pathway to scale for waste management and treatment that includes supercritical water oxidation. So excited about that. So visit that website for more information. And next slide will be my last slide, just a conclusion. I hope I was able to convey the excitement that I have about SCWA, because I think it's a really transformative technology for biosolids and FSM treatment. We address all the organic contamination as well as pathogen. The process is very sustainable. It doesn't require any chemicals or consumables, and it allows resource recovery. And so follow us, stay tuned, stay in touch for more news and seeing these systems being developed. Thank you very much for your attention.
Thank you, Professor Mark, for presenting us like a very promising transformative technology, like where you have said like modular units can be prefabricated and the technology can be implemented in it. And it was very interesting to see the different kinds of waste, including the recalcitrant compounds, pharmaceuticals, microplastics, all can be treated. Thank you very much for the wonderful presentation. Um, Next, we will move on to, I will invite Mr. Sun Kim once again to the forum to showcase the status of adoption of ISO 31800.
Great, thank you. Yeah, and just as a really quick recap of my former presenters, this really is exciting. I think there's some comments about cost and you know, these are technologies and intended to address specific concerns about pathogens and treatment. And of course, if there are other systems that are better able to do this at a lower cost, that's always of interest. But it is really exciting that these systems are coming online. And as they become commercialized, they will become cheaper. You know, imagine the handphone, you know, when they were thousands of dollars and you could only talk to people on them. Now they're supercomputers in your pocket. But anyway, with that, for the interest of time, I think Dr. Priyan Arumugam also asked a very similar question related to national adoption of standards. And so with that, I'm gonna, I don't have a presentation, but I'm gonna share a screen. And so I'll just go through this really quickly. Sorry, I think I'm sharing the wrong screen here. Share screen there. Okay, so I think you can see, you know, just whatever web browser you're using. If you just go into ANSI.sanitate and ANSI and sanitation, American National Standards of Sanitation. If you go to that website, it's I think Dr. Dinesh mentioned how, you know, this is a great website with lots of information. You can download standards. You can learn more about the various standards we've talked about in all the webinars. But if you go under standards and the drop down, go to the national adoption map, you will see that it tracks in numerical form the topic of webinar number 2, the topic of webinar number 3, and specifically 31800 is not explicitly aggregated here, but if you hover over countries, you will see, for example, Senegal has adopted at the very bottom there ISO 31800, along with the standards for the reinvented toilet or the household scale toilets, as well as the guidelines. And other countries, such as I think the DRC has adopted it, ISO 31800 in the middle there. I believe Bangladesh has also adopted it. So there are a number of countries, and you know, further to Dr. Priyan, you know, South Africa is in the process, I believe, of looking at adopting 31800. So this is a great resource to look at in terms of national adoption. But again, the standard and its implementation as a national standard, and then also the technologies, it's all of these things have to come together to really resolve these sanitation issues. So anyway, with that, I'll go ahead and stop, and I believe there might be some questions. So thank you.
Thank you, Kim. Thank you very much. There are a few questions. So for the interest of time, like I thought I can read out certain questions, and certain questions have already been answered by the speakers by seeing them in the chat box. The first question was like, which countries have adopted the standard? I think for that, the map has given us the answer with the support of Kim. He has already explained which countries have adopted. And there are few other questions. I think it can be certain questions I can directly ask the speakers. Like there is one question. I think this is to Mr. Christian. Like when your presentation was going on, this question was there in the chat box, like with respect to heavy metals and dioxin. So is there any comment on that? So it has been shown that it is not supposed to be in the septage. And do we have any comments with respect to the heavy metals and dioxins?
Yep. So I didn't reply because I thought we could use this time to discuss. Yeah, so you're correct. Heavy metals and dioxin is not supposed to be in septage, provided the septage is fecal sludge and urine pure. But the thing is, we've got feedback from our partners, Mansoor, Mark, and other partners who are operating the plant, that they cannot control what's coming in. And sometimes I've heard, I haven't seen myself, but I heard sometimes they even find batteries inside the septic pits. So that's the problem. So the committee had to understand two things. Are we going to collect feces and urine and load into the fecal sludge treatment plant, which is about maybe 50,000 people per day capacity, which is not possible. So they have to gather the whatever input they have operationally. And then this is not controllable. Whatever comes in. They only have to conduct a baseline and then let us know what is the baseline about. Yeah, so that's the reason why currently the heavy metals and dioxin are inside as well. Yeah.
Thank you, Chris, for the answer. And there is one more question. I think this will be in the mind of many people. Like when we talk about thermal technologies, like are they financially like sustainable option? So especially when we talk about thermal destruction like combustion and pyrolysis. So what is the economics behind it? What will be the byproduct? Will it be of, I think you've already answered some part, like it will be of use in terms of fertilizer and other products. But then there is a question on the economics part of these process. I think Mansoor will be able to answer this question.
Yes. Let's say, let me address it in different way. And Sun can correct me, he's from the aircraft engineering. There is there's minimum aircraft company that have some economic variability. All these aircraft companies, they get money from the states. It's not variable, but we should run the the aircraft. But if you go to South Africa, Air France, a lot of companies, they look like having economics that work well, but they're not working well. They're losing money. So they get money because it's a primary need of the public, of the community to move. Same for the sludge. There's a primary need to treat the sludge. From the beginning to now, people were focusing on treating the wastewater, not the sludge. They used to treat the water. The sludge, no reduction will happen and no killing pathogen of the sludge. It should happen. That's to make it very simple. But another question is that when we just did this first survey in 2014, we ran this machine in Dakar. We were trying to learn, can we have some byproduct that can be helpful? We realized that yes, with a good marketing plan, you can have some very interesting byproducts. But again, when it comes to cell, it's not sanitation, it's a cell. You should address the problem as a cell person, and you should use the strategy of selling to sell the byproduct. If you apply the right strategy, you apply the right packaging, you can make it very profitable. But if you're not very good in strategizing, you can be sustainable. You know, there's sustainable and profitability. So if you are very good in marketing and you have a good strategy, you can sell it 100% very well. We tried in the first one. In the second generation, we realized that the demand of pavers is so high that we cannot follow. So they just think about, okay, how we can produce more ash to just follow the demand, because people ask for organic pavers. So it's all how you manage it. So economic sense is behind. If you have an investment, you go to the bank, you ask for money for investment, they will not ask you the cost, initial cost. Initial cost will not tell you the right details of your investment. It will just give you one part of the price. But the global cost is what is interesting. Initial cost, CapEx and OpEx. If you take the global cost of of omniprocessor. You compare it to the global cost of traditional FSTP, there is no photo, there's no pictures. The OP is more profitable. There is nothing generated in the treatment plant. You take waste and you treat it, and there is nothing coming out of it. There can be cells. You take waste, you put in the OP, and you generate some revenue. Normally, if in mathematics, it's like you take some value, and at the end you see there is from nothing, it's like infinite, to make it a very mathematic way approach. But the thing is that if you ask for money going to the bank to invest in the OP, they will ask you the return of invest. For the OP, it shows all the business plan that the return of invest is less than 5 years. The lifespan, they will tell you. Okay, come on, Sen.
Yeah, if I could add one thing, I think Mark wanted to answer one question about oily, but if I could just add, just a couple of points here. It is all about economics, and unfortunately, sanitation typically is a drain on the country, or oftentimes it's just ignored. So if there are other more economical, better, more feasible, protective systems, that would be great. But I'm not personally aware that there is such a system as Mansoor has mentioned. And so in the end, I think you could, especially at the beginning, it will be more expensive, but in the end, the cost will come down, and the economics. What is the definition of poverty? Or poor, being poor. It's where the economics is not working for individuals, nor for the community, nor for the country, and that is a big driver here. So anyway, but I don't want to belabor this. I think Mark, did you want to answer the question about the oily, the bottom oil, or? Yeah,
I'd love to address that, because I think it's a good question. Good question to talk about the applicability of the supercritical water oxidation technology to treat all kinds of waste. And so I put in the chat that the short answer is yes, we can treat oily waste, and we've actually done it in 374 water lab on a small unit to demonstrate it, and we've treated some waste oil, waste cooking oil at so it's not oily waste, but it's similar at Duke on a larger scale. The one thing to remember is that oily waste is a supercharged fuel, and we've designed a unit that is made to run on fumes, and so we have to look at the calorific content of that oily waste, and it may need to be blended with some other waste just because it is very energetic. But the short answer is that yes, supercritical water oxidation is also an omniprocessor in the way that it can take all kinds of waste, slaughterhouse waste, waste paint, anything organic that has energy content. And to the question of cost, I think we expect the system to be in the range of a couple $1 million, but with the prices needed to be fixed for resource constraint area, and the cost also going down with the size of the unit. And we are working on business models and figuring out. It's difficult, of course, to compete when the alternative is dumping in the environment, but we're working towards understanding the cost benefit to society when this waste is not being released in the environment. We're working on figuring out how to monetize the fertilizer and the water, but also the heat. There's tremendous value to the heat.
Yeah, I thank all the presenters. I think now we have come to the end of the session, and we have almost tried to answer the questions, and presenters were actively commenting on the answers. I mean, in the Q&A part in the chat box. So thank you very much for that. So we had excellent presentations from all the 4 speakers, and we have also have good comment from Dr. Chaurasia, we have to look into the villages, rural parts, where these kind of technologies could also be implemented. So thank you for the comments, and thanks once again to all the presenters. Now I would like to invite Asim, who's a senior program lead from CWAS, to give a vote of thanks for this session and for the previous sessions as well. Over to you, Asim.
Yeah, thank you, Devsena ji, for this handover. First of all, I would like to thank all the participants who have still stayed back on this call, and we appreciate your attendance as well as your interest to know on this systems, on these ISOs. We would like to also inform all of you that we planned this webinar since July 23, and it's almost, we'll be doing a year now. And we have done this 4 rounds of webinars, and it has been a great exercise, learning exercise, I would say, for us as well, where we have also learned about these ISOs being in this sector. We had around 500 plus participants across the globe who have attended these webinars. The resources, let me tell you, the previous webinars, I think what Sun was hinting, the intro webinar, the ISO 3500, 24521, as well as this webinar presentations, as well as the video recording will be available on the CWAS as well as IIT Palakkad website. So we will also share it with all of you who have attended this webinar. In case you have any queries regarding the ISOs, please do reach out to us or to IIT Palakkad for the same, and we'll help you connect with the right people to understand further. I would like to thank all our key speakers. I think it has been an excellent journey. We had almost 12 excellent distinguished speakers. Just to name Leslie from NC, we have Chris from TUB, as well as we had me from TUB Sud, Ms. Jyoti and Alok Kumar from National Nepal Bureau of Standards, Bhavna and Rosie Singh from Info, Frederick, Ron, Professor Mark from Duke, and Mansoor Fall. And I would like to specially thank Sun. I think he has been part of the journey since the first webinar when we started this discussion. He has held the fort there. So thanks, Sun, for being there. I would also like to thank the co-organizers, Roshan, Sakshi, and Vivek from the Gates Foundation, who helped us connect and asked us to think about these ISOs and bring it to the larger world and to the sector partners who are working on this. I would like to thank our partner from IIT Palakkad, Dr. Devsena, Guru Prasad, Sarosh, and Dr. Anuradha Shankar, with whom we started. So thank you for being partners with us. Last but not the least, our team, Professor Dinesh Mehta, Dr. Meera Mehta, and my colleague Jigisha. Unfortunately, she had to leave, but she has been holding the fort, as well as from our side, Jigisha Jaiswal, who has led this webinar. So thank you all for joining, and we hope that this discussions continue and this is not the end. Thank you very much.